All right. Hi, everyone. Thank you for joining the fourth week of IEEE Symposium on Data Analytics and IoT. My name is Fatemeh Jalali, and I'm one of the organizers of this symposium. And I'm going to host this session on behalf of the committee of this symposium. As you may know, this symposium is a series of technical talks over 8 weeks, and it's going to be around the technical concept on IoT, data analytics, and the related topics, which is organized by IEEE Victorian section. And more specifically, it's a collaboration between IEEE CIS community, IEEE IoT community, and IEEE Melbourne Uni student branch. Before introducing our host, I would like to let you know this session is going to be 1 hour session, and our guest speaker is going to talk for about 40-45 minutes, and we're going to have 15 to 20 minutes for Q&A at the end. You feel free to write your question in the Q&A session, or at the end, if you would like to speak, just raise your hand. I will unmute you, and then you can directly ask your question. All right, today we have very special guests, and we are very lucky to have Tim Cara from GeoWAN. Tim is actually the founder and the board member of GeoWAN, which is Australia's public LoRaWAN telecom. Tim is an IoT specialist, having first-hand experience of IoT network and ecosystem across multiple sectors. He recently joined IoTSec as an executive team member to work with Australian stakeholders on improving the national IoT security roadmap, which we know that the IoT security is a very important topic, and he's actually going to talk about this topic and share some insights about IoT security with us today. So I'm going to stop here and hand it over to Tim to talk about this interesting topic. Tim, please.
Okay, well, thank you everyone for the great honor of being able to present. It's always a pleasure to have anything, any collaboration with the IEEE, and especially being from Victoria within all of the different sections within Victoria. And first of all, I'd like to welcome everyone. I hope that the presentation and the topic at hand is of relevance. It's definitely growing in importance, so that should you know, give you a bit of an indication into which way the market's going and the potential vulnerabilities that we have, and certain areas of the market that we are currently evolving under, and the direction of potential opportunities, and also some potential bits of harm as well that could happen if the IoT ecosystem isn't secured up. And my presentation today is going to be in regards to IoT security. And
Tim, sorry to interrupt. We can't see your slides.
Oh, you can't see them?
Yeah, no, I see your folder, but not this slide. I mean, if you're
really?
sharing, yeah. Maybe you're sharing the other screen if you have two screens.
No, I don't.
Hi, Tim. Would you mind stop sharing and sharing it once again, please?
Yeah. Okay, can you see it now?
Yeah.
Okay.
Yes.
So my topic today is going to be around an introduction into IoT security. It is a very broad area. It's not just a soft security concern. It is a hardware and also a access network security issue, and being an all-encompassing solution, it relies on a secure ecosystem. And with these slides, please use them. Just give if there's anything that you find useful, please use them, but just please give it an accreditation to IoTSec Australia. All those terms are on our website. So about IoTSec, through the stages of digitalization that we're all going through, we're trying to build a safe society, and IoTSec is formed as a industry initiative, pretty much to raise awareness and promote secure practices in the IoT space, and the ecosystem to effectively build a better and safer digitalization roadmap of what we're going through. And IoT will be at the center of a lot of emerging technologies, especially from data gathering all the way through to intelligent contracts via blockchain, and also the data given at a post-event type of analysis will allow us to find better outcomes of our world and our society. As a non-for-profit, it really exists to benefit both industry and society at large, regardless of the application. And it's important to keep in mind that even though applications are judged as critical and non-critical, they still all have a certain degree and a certain amount of complexity about them, where you, as a member of that ecosystem, need to be aware of the potential hazards and potential risks posed by a flawed system or just not enough security. And one of the things that humanity and what we can see now in the world of the digital damage era is that it's critical infrastructure and governments who seem to cop the brunt of the cyber attacks and the different things. And a cyber attack on an IoT architecture is considerably different to a cyber attack on a IT system. But the IoT system is still responsible as being within the whole ecosystem of IoT. And I'll go more into that in this discussion. So the main factors that are driving IoT in general are people and technology. And as we become more reliant on technology, the way that we work, live, and our roles are changing, the demand for the reduction of resources, both human and material, is driving an evolution of a kind of sort, kind of in that same thing that happened when email replaced majority of the letters and face-to-face documentation. And this evolution is referred to as the Internet of Things, and it's not a new concept. It's been around for a while. It just really hasn't been at this scale where we're talking about possibly millions of devices. I will stay away from the term trillions or billions of devices, because we're just sort of scraping at that millions mark now of true IoT devices. And the technology with this is both changing our social and living environments. We now have central home management systems that are a technological fix for finding out information, downloading a recipe, or just generally letting you know when something's not right around your house. It could be sensors connected up through a central hub. And of course, in a greater city type of an environment, you have the smart city taking over that role of managing the citywide infrastructure and the livability of people, such as the street lights, that they're at the right amount of light, that the air quality is good, that the water quality, that we're not damaging the environment. And as we become more urbanized, those types of install and forget monitoring systems are going to play a more critical role, as we all know. But how are we going to make them secure when they're out there? They're generally available to the public. Someone maliciously can damage them, which does happen. And one of the one of the things that we have to consider when it comes to scale is obviously the adoption environment, and that will drive all of our respected industries into a new era. And as the .com era changed the flow of communication, IoT is going to change the way in which our world is monitored. Kind of Nikola Tesla foretold that the world will be a big sensory system, and we're sort of at the cusp of that. And it can be a good thing, or it can be a dangerous thing too. So one of the key areas which gets a lot of focus on security at the moment is the cyberspace. And it's not as simple to call IoT security cybersecurity. Cybersecurity is a component of IoT, but in the scheme of things, cybersecurity is a minor role player in the security ecosystem. In fact, it should probably only make up roughly between 10 and 15% of the whole security variables and different requirements of a IoT system. So in many times, I've said that IoT is a composition of devices, which is what things comes from. Access networks, which are your wireless communication system, or wired, it's still an access network. And your IT network, which in the ecosystem takes the information from the device via the access network into its database or into its analytics on the fly system and does whatever it's been programmed to do. And sometimes, in fact, a lot of the times, the device manufacturers don't understand the security requirements of the IT network, and IT doesn't really know the issues or the problems faced by the access network, and the access network can be guilty of not being forthcoming with their vulnerabilities to the device manufacturer and the IoT network. And that's why sometimes you do see that when it is an all in-house solution comprising of devices, access network, and IT network, they generally do tend to be a little bit more well formed. In that kind of on the retrospect of that, one of the challenges that I've faced over the past five years in IoT is a mentality from IT network providers to have a very, very strong and robust IT network cybersecurity program, but they don't really put that much into the critical nature of the devices or the access network, because to them, they just want the data. They really don't, it's not really a software engineer's big part of their one, education, and two, requirement of the job to focus on the device vulnerability via access, or even a simple man-in-the-middle attack via an access network. They just look at make sure that the data is sort of coming in regularly and they're happy. And at the same time, the device manufacturers are in a position where they have to commoditize their product in order to make ends meet. And of course, when you start commoditizing something and cherry picking even the components out of it, sometimes not the best components, and also other variables are included in the device manufacturing and design, or the concept. And of course, the access network, well, the access network has been one of the challenges of recent times, given that the complexity of personal, local, and also wide area networks, and even off-Earth type of networks, or outside of, or orbital networks such as nanosatellites and fixed orbital satellites are are sort of now making a move into the IoT security space. And that sort of is going to be the main area of my discussion for this presentation, and some of the challenges and some of the considerations more so that I've realized and come across over my 5 years as a founder and the CEO of a IoT telecommunications company, that I've had to challenge myself, and I hope that anybody listening can extract some usefulness out of my pain, and hopefully you can benefit by just not having to go through some of the things I've had to. And some of the segment challenges. So the 3 sectors, you have the device, and one of the things that is very, very much overlooked is that devices pose the single most complex IoTSec challenge. The mentality of just buy it cheap and $10 a sensor really, really doesn't work. Most of the times I've found that those types of claims are venture capital backed, where there is a company or an organization who just has thrown some money behind the devices and just wants to prove some results, claiming those things. And of course, once you start working with component distribution and OEM, ODM manufacturers, you will realize that the $10 mark is not really the acceptable, and devices are still around the $75 to $300, $400, $500 mark, depending on the complexity. And with so many use cases developing and constantly being brought out and never quite fitting the use 100%, we're seeing a rush in just getting something out there. And that in itself creates hardware vulnerabilities, because when people overlook cryptography, or they overlook certain key management of the device, or the way in which the device communicates, any anomalies, does it pick it up, is it encrypted at all? That's some of the challenges that come from a device. And once again, IT networks suffer from this. As an example, if you had a blockchain-based solution and you claimed that it was a private blockchain, but your device is communicating unencrypted and anybody can eavesdrop in, all of a sudden you're making a false claim in the market, quite possibly, and your blockchain is definitely not private, except for you claiming it to be, but those parts are overlooked. And that's the same thing across the devices, such as metering systems, metering solutions, certain critical infrastructure as well. It's not necessarily a good thing to have the data just open and public, because it's not information, especially critical infrastructure data. Our water, our electricity, gas and oil is not really something that you want somebody to be able to interpret, because the devices are built in a particular manner that doesn't really focus on keeping that data private. And of course, there is the physical attack as well, where somebody can, if there is an access, both wireless and via a port, they could reprogram or reprovision or commandeer the device to do things that they want it to do. And a lot of the times, some infrastructure or some IT systems and even network systems may not actually pick up the anomalies. And that's something that we could possibly see a lot more of if we don't start looking at some of the guidelines. And at the moment, majority of them are voluntary, but you can see that the European Union and the Singapore government and the American governments are now looking at putting a lot more responsibility onto the device manufacturers and device designers to incorporate security, so along that line of device access network and IT networks, there's nobody pointing fingers at someone. Everyone has to do their best. And being a telco provider, I see the networks as one of the most difficult to explain to somebody. People, a lot of, there seems to be a mentality in the market of picking up whether routers or other types of comm systems or Bluetooth systems, and just putting these networks out is just the way to go. But there's a lot of complexity behind it, and it is a regulated industry. As much as there are classes to it, they are still class regulated. So you may be able to do something on it, but you may not be able to do something else on it. And the access network's duty is to relay the data from the device to the IT network and back if it's a control system or automation system. And how these networks are deployed will affect large deployments, and also they have a large impact. And the reason why I said large deployments is because if the networks are not calibrated in such a way where they allow coexistence of other networks, then you start running into QA problems, clashes of information, and it just ends up a big shouting room out there in the spectrum space. And spectrum, of course, is more valuable than gold. So you have to use it very wisely. We can't just create more spectrum. It's all we have. And once again, then we end up with the IT network. And the IT network is where all the data comes through. I can see that there's some wonderful speakers on data and analytics and databases and all that. So I will let them go into the different tasks, but it's always important to remember that the IT network is the main interface with the user of the solution. So the granular data ends up in the IT network's user experience. It's part of the user experience. That's where the data is extracted. And it is really important to make sure that that information, once it's stored, is safe as well. Once it's stored, it's not susceptible to having anything on the fly from the device and the access network, but that's where it becomes a data breach, and also could be used for the wrong reasons. So the considerations. So devices have a number of weaknesses and vulnerabilities, and a couple of those can be found in just essentially the hardware itself or its componentry, the encryption, and also the access. All devices have to be told what to do. Even though it might be a temperature sensor, it has to be told what it's going to be doing, who it's going to be talking to, how often it's going to be talking, what are the frames that it's open, when does it go into sleep mode, or does it not go into sleep mode? And all these things have to be calibrated to make sure that the device is functioning correctly. And the security of the devices is done via keys, and the keys are generally either embedded or they're transported over the air. Me, myself, I'm not a fan of over the air transportation of any security keys. I don't think that it's a very good practice. But of course, it allows a bit of flexibility in where the device is and who you're using without having to manually override it. So once again, it is one of those gray areas. I'm not a fan of over-the-air activation or over-the-air reprovisioning, but others seem to like it. It's probably because they just, once again, want that ease of being able to change things without actually going out there and bringing back the device and manually doing it. And access networks are out in our physical world. They're on top of our telecommunications towers, they're on top of buildings, they're on top of CBD buildings, they're in basements, they're in people's houses with a Wi-Fi network, 5G, microcells are going out, we've got satellites, we've got Bluetooth, we've got all different things. Wi-Fi 6 will be coming as well, which I'm personally excited about. And these access networks have a lot of both complex weaknesses and also regulatory considerations. And there is no telecommunication system that isn't regulated. All of them are regulated, and it's done via whether you are the seller of the network connectivity, such as GeoWAN is, or you're the ISP who's allowing someone to plug into the internet via your license. It is all regulated. However, they're not responsible for your security though. And that's some of the considerations of access networks being affected by, I mentioned before, eavesdropping. So when there's a message going via the air and it's not encrypted, somebody can pull that information down. It is a very very known aspect of IoT security. And I mean, anybody with an elderly parent or somebody with a young child, and they may have a GPS tracker on them, you don't necessarily want somebody to be able to listen to that GPS coordinate, know the person who it belongs to, and know the child or the vulnerable elderly person who is being monitored for their health or safety reasons. The other one is flooding of spectrum, and IT networks are aware of what a DDoS attack is, but the same thing can happen in the spectrum. So it can happen in the access network where there is just too much information and data going through, and it generally seizes or locks down the communication access. It's kind of like when there's 100 people in a room all shouting, chances are the person next to you is not going to hear you, let alone the person across the room. But when everyone talks in a fair, orderly process, then everybody gets listened to. Man in the middle attacks. Man in the middle is somebody who, or is a consideration where somebody will either maliciously or not maliciously, but just observantly sit there and be the man in the middle. It's a little bit different to eavesdropping because man in the middle can send a command because they have the access. And man in the middle attacks can happen in a number of different ways, and they definitely have to be monitored on an ongoing basis by the access network provider. And that's why I always suggest to go with a licensed access network provider who has those safeguards in place, who can monitor data usage as opposed to data being transmitted over, and you can definitely see some of that. And of course, encryption. Encryption is key. Encryption is a necessity as far as I'm concerned. If a system or solution is not encrypted, I don't go anywhere near it, because it just allows all of the negative things that I've just said to happen quite easily, and you're not even trying to encrypt it, which makes it even worse. And of course, IT networks, being at the end of the ecosystem, have many well-known vulnerabilities. These can be malicious hacking, ransoming, data leaking, and evolving threats. And all of that is compounded by the considerations of the device access network into the IT network. And that's where the due diligence of anybody, wherever you are in that stack, or whatever project you're working on in that stack, you should have a complete due diligence system. And I do believe that self-regulation is a lot more important than government or state regulation. We don't work with somebody who is not a registered company. We have to have a registered organization. And we also put various different requirements on things such as I mentioned, like encryption, and also where the data is pointed to, where the data is going to. Does it go through somewhere? Of course, we claim end-to-end encryption within my company, but if there is a device that's using our access network going to a third-party software that then goes to the IT network, we don't guarantee end-to-end because it's not going to the end user. So we tend not to use entities that are a third party in between my organization, my company, and the end company, such as your IBM, Oracle, or Microsoft, or even a private server. And some of the evaluation strategy that I can recommend for devices is based on multiple factors. Some of these are national regulation. It is important to follow Australian regulation. You have to follow Australian regulation on antenna, on module, on all different things. It is not heavily policed, but you have to follow it. And the risk will inevitably come back to the company who didn't do the correct due diligence on what they used in their either product or in their system. Global standards. I'm a fan of global standards. They give everybody the same type of playing field. It makes understanding what your device is a lot easier, and that can be the communication standard or the different standard in whether it's an IEEE standard or ISO standard. And encryption type is very, very important. As a minimum, we recommend AES 128-bit encryption, and we do go higher up to military grade encryption, depending on what it is that we're trying to achieve. There has been a discussion around the producing party or the manufacturing party of the device. Please be very cautious about who manufactures your device and where you're sourcing it from, because there are international sanctions at the moment, and those international sanctions do affect us in Australia. My company always maintains an Office of Foreign Asset Control compliance with Peter Dutton's office. We will not work with anybody who is related or works with or has shareholders from any of those sanctioned entities, full stop. And that is the kind of level of security and also compliance that I'm talking about. If your product is going to actually meet those safety requirements and security requirements. Componentry, well, that's another interesting one, because there has been safe components that have had backdoors in them that people have been able to extract data from, and that happens on the device level. So that can actually mean that the device itself skips all of the access network and IT network security systems in place and communicates direct to whoever it does. And when you buy a device off the shelf, a lot of the times people don't have the expertise to actually point their finger at what a particular component is doing. So it's best to buy off somebody who's a reputable producer or a reputable source. Design features. Design features are quite interesting in that design features do mean that they are less likely to be hacked. And those design features could be single provisioning at the manufacturing source and not just on the fly, as a lot of people like to do and set their own keys, which may not be correct. And then, or you can have an encrypted service via a cellular connection, but the Bluetooth isn't, but you can reprovision the device via your Bluetooth connection. And that's automatically a failure there. And of course, compliance. There are compliance requirements within Australia for turning on devices. It is a requirement to do, and strongly advise that all devices, that you buy either for yourself or research or for your company or for anybody, it should have a local responsible entity guaranteeing it that it is to Australian standard. And luck with that we have with Australia is that we also have AUNZ, so we can generally use both. Access networks can be evaluated in a much broader sense. Some points are the network requirements. What is it that your IoT system is trying to do, and does the network actually have that capacity to do it in a safe way? Sometimes going so low in data rate doesn't allow you to encrypt it. So then, are you actually benefiting anything? I say no. The standard protocols, as I mentioned, there's Wi-Fi, 4G, 5G, LoRa. These are international standard protocols, and they give a level playing field on how to communicate and configure the devices. Of course, there's regulatory compliance, labeling, all of the different power, transmission power. Of course, trusted provider. Please use an Australian registered telecommunications or ISP provider. They are very important because they are licensed, and there are a lot of components that that we have to provide to the Department of Homeland Affairs about how we run our networks. And it really is important that in IoT, we understand that. And if a company is not capable of running a telecommunications license, they should use somebody who is licensed. Over-the-top providers are definitely a big no-no in IoTSec because you have no control about where and what they do with the data. You have, if the data is decrypted at a network layer level, it means that wherever they are in the world, they unencrypted take your data, analyze it, store it, use it, sell it. It's out of your control. So an over-the-top vendor would be somebody, or a provider would be somebody who provides you with a system whereby you can use a free or open, generally free or open source, and then there are community considerations and how great it is, but really, is it that great when we're putting community information such as counting people and other things onto an over-the-top provider who's outside of Australian jurisdiction with our data? That just does not make sense to me. Geographical location, this is very important because international treaties have got different requirements, and they do not consider Australian foremost to their own. So one example of the geographical location where there can be some consideration is if you host a data center in America and it's not Trump related. This is a consideration that's been going on since the Patriot Act was signed, that any data that touches US soil, the American government has legal access to access it if they want. So the way to mitigate that is keep the data in Australia. It's best to know our own. We know our own. We elected them, not some other country who, if you know the data center, by the way, because sometimes that's also a consideration, especially with over-the-top vendors, you really don't know where the data's going. They say it goes here and it goes there, but it may not. And of course, IT networks luckily have many reputable providers. Some evaluation points is a data storage security. Is it encrypted? Isn't it? The system vulnerabilities, so penetration testing, other types of certificate analysis and reviews constantly is very important. Of course, I'll go back to the access network database location. Where is the database and who has access to that database? The storage encryption, third-party access. Third-party access is some little term and conditions that they can provide that data to anybody else who may be paying for it or access it if they pay for it. And it really brings up the question of, well, if someone else is buying that data, is the data sovereignty really yours? Does the data really belong to you? And if you have a system where there's a strong requirement on the data staying confidential to the user and the producer of that data or the procurement, then you really need to get the data sovereignty under control. And then there is IT network and other types of compliance and regulatory compliance, such as GDPR in Europe and other types of forming compliance that we'll see more and more of come out. And of course, one of the big questions of IoT is, well, security, but there's also privacy, and security focuses on the vulnerability of the IoT ecosystem and the various environmental factors that make up the final solution. So is your device security right? Is your network, and also is your application? But privacy is something that is really fundamental in your decision making. And you should never forego privacy because it doesn't belong to you. The privacy of the user belongs to the user. And open data can be good if it's an opt-in, but at the end of it, you can't give away very granular data such as somebody's water meter on a live stream, because criminals may find patterns when they're home, when they're not. They might rob their house. The same thing might be of officers. It might be of security alarm systems. I don't even want to go near medical devices because medical devices have just so much to lose if the privacy is not maintained. And one of the best ways of doing the privacy segregation between security and privacy is you don't transmit identifiable data such as TIM Cara GeoWAN. You don't transmit that in the GPS coordinate or the temperature sensor or his gas meter or his water meter that, well, you know, this morning at 7:35, Tim had a 5-minute shower. You just say a water meter with this serial number had this much water consumption, but you have to separate who's the consumer of that data, and they have to access that data via a separate platform, not in the data stream itself. So that's a very, very important consideration with vulnerable people, elderly, children, any type of asset, any type of home-based automation system. Keep the person's information, personal information, separate from the data that the sensor is procuring. Simple as that. And the next slide is about the collaboration with IoTSec. As I mentioned, IoTSec is a non-for-profit, and its main interest is to work on the evolution of IoTSec in Australia. And we seek partners from all industries in the IoT ecosystem. So if you're interested, please email me at tim@iotsec.net.au, and that's presented by me. I'm as mentioned earlier, I am a non-executive director at IoTSec. I joined recently, and I will be looking to progress into an executive role there, as in a executive director role. And I do really want to see you know, a safe IoT ecosystem for all of us, irrespective of my businesses. It's just the thing to do in the current world today. And if there are some things that are not necessarily industry secrets, but just any type of IoT security query you may have, please feel free to reach out to me on my email address provided above. And thank you, everyone, and I'll hand it over for any questions if there are any.
Yep. Thank you very much, Tim. It was wonderful talk, and thank you for sharing the insights about differentiating between cybersecurity for IoT systems versus IT systems, and also like explaining about security requirement in different layers, device, access network, and IT network. That was wonderful. So now we have time, 15 minutes for Q&A. So you feel free to write your question in the Q&A section or raise your hand. I can unmute you and you can directly ask your question.
Hi, Tim. Very great talk, this Sattar, and thank you. Really great talk. I have one question as well regarding security, and you mentioned about encryption as well.
Yep.
This is IoT mostly. I think if we have only considered the raw data, collecting lots of big data in IoT, it is not the main purpose of the IoT devices. Probably one of the things important is how we can get useful information, use AI, artificial intelligence in an IoT. Regarding encryption, I think that is some kind of conflict as well with the AI technology, because if you have some kind of encrypted data, probably AI technology can't work there. But other side also, privacy, security, probably encryption now is one of the solution. What is based on your involvement in IoT security and also GeoWAN, you are director of those. So what is the solution for these things? So how we can safely use AI while we have a good also security and privacy as well?
Yeah, majority of because of the sheer amount of energy that it takes to power an IoT device, you will notice that majority of IoT devices will be very, very dumb in what they do, very, very sort of simple in what they do. You're not going to have a water level meter with a calculator on it. Otherwise, you just put an iPhone out. So the use case is going to be determined by a device which gives the information. That then gets carried through, and this goes into your question about the AI. The AI is housed within the IT ecosystem, and the encryption should be already done by the time it gets into your IT ecosystem, whether you're using IBM Cognos or some other type of AI system, or you're using Oracle for your AI, or you've written your own. By the time that your AI system gets it and is analyzing that data, it is already unencrypted, right? So that's how it should be done. The AI system should, in my opinion, it can have some things on the device, such as communicate here or communicate there, but it's not necessarily a good thing to leave too much memory on a device, because that also is a vulnerability on the device. So your database and your AI solution should already receive the data decrypted, ready for it to use. So there really isn't, I can't see a way of that being a conflict, because it's already decrypted by the time that the AI is using it. Does that answer your question?
Yep, thank you.
Yep.
Okay, we've got a question here. The question is that if we are building our own IoT system, how can we secure common devices like Raspberry Pis?
You won't be able to build a scalable solution with the Raspberry Pi. They are good for trial and error. They are good for proving a concept, POCs, pilots, perfect. But you're going to realize that if you ever get to the point where you're actually going to provide a solution and a hardware solution at that, whether you're using the Raspberry Pi as the access network or you're using it as the end node or the end point, the end thing, you're going to realize that using a Raspberry Pi is going to pose certain challenges. And I'll list some of these challenges. If you got an order for 10,000 Raspberry Pis, or a solution that you incorporate 10,000 Raspberry Pis in, you receive the Raspberry Pis pretty much unconfigured, correct? Yeah. So then you actually have to sit there manually rewriting what the Raspberry Pi is meant to be doing for 10,000 devices. There is no way that will be economical. If you use the Raspberry Pi as an access network with, say, a SIM card on it or plugged into your Wi-Fi, you'll realize that poses certain other challenges. Generally the channelization is a lot lower. You won't have as many communication channels, which will also mean some of the Raspberry Pis communicate on one channel, as an example. It depends on how you, of course, set that up, but you will come to scalability issues, if not at the device, then at the network, or if not at the network, then at the device level. And it's just, it's just something that once you get beyond a certain point and you go to manufacturing and proper industrial design, you'll actually realize that there is no way that you can use a Raspberry Pi. I don't think that Raspberry Pis were designed to provide industrial, very reliant critical infrastructure type of solutions anyway. So by default, they're not for that. There's other producers. That's where you start working with your microchips and ARM and Arrow, some of the component distributors on, and some of the larger OEM manufacturers who, as an example, we work with, who get the mechanical design ready and everything's done and ready to go from the production line. Because if it takes you 10 minutes to recode a little Raspberry Pi or an Arduino or something, how long is it going to take you to do 10,000, and how much hours are there in a day, and all of that, all of those types of considerations. And you have to package it. So I think you can work out it's not feasible. Yep.
Okay, thank you. So the next question is that how do you handle crypto key management without visiting every device physically?
Activation by personalization, or activation at programming. So basically the device it's kind of like your mobile phone. When you get say an Optus mobile phone or a Telstra mobile phone, generally it's already pre-registered because they put an order in for 10,000 of those phones, and they were designed and provisioned in that way to work on that network. And once you put their SIM card in, which comes with it, it starts working. So with the devices, whether it's Wi-Fi, Bluetooth, or any other modular-based technology, or SIM card-based technology, or other types of IC level, you can even go down to IC level where you don't have a module, you don't have a SIM card, you just got a little chip in there. That's one way of doing the Arduino question. You go down to IC level, and the IC does all of the controlling. That's a way. So your provisioning is at the start, and of course that really rules out using third-party devices unless you have a considerable order quantity, and majority of hardware manufacturers have an MOQ, so a minimum order quantity of between 3,000 and 15,000 devices, and they generally have to be paid up front. So once it comes off the production line, they're ready to go on your system and solution. So I hope that answers it. Okay,
thank you. The next question that we have here is, thanks for your wonderful talk. And then it's mentioned that, as you mentioned, at device layer, there is minimum encryption requirements such as AES 128. So do you think there is the need of lightweight encryption for energy efficient devices working in ecosystem, having minimum resources?
Okay, anonymous attendee, can you please answer what does minimum resources mean? Is that financial, or is that resources for the actual knowledge of how to do it? Can you answer that? Well, in the meantime, I'll try to answer it my best. The way that question poses two different answers. The answer is you can either build your whole solution around an encryption standard. Ours is AES 128. There are other encryption standards, of course. You build it around it, and you program and provision the device in such a way that it's pretty much designed around the use case, designed around the expectation. And the most important thing when it comes to energy efficient devices is start with what you want to achieve, how long you want to achieve it for, and select the correct battery. don't try to run a device that communicates every 10 minutes with an open time of a couple of hundreds of milliseconds for the transmission, and you put a coin cell battery in it and then claim it's going to last for 20 years. Put a proper battery in. So you might be charged an extra $1 or $2 or $3 or $5, but it's better to have a bigger battery in there than a smaller one that just doesn't do the job. And going into the micro device area is something that's going to take some time. In fact, today I had a very interesting conversation with a partner regarding how we can bring energy saving into devices, and of course one of the ways of doing it is sleep mode. You put the device into sleep and then it communicates once every 10 or once every 30 or 60 or 12 hours. You can have the devices communicating. So there are different ways of having a look at it, and if I guess if your question is having minimum resources in a monetary sense, learn how to do it yourself. One of my business partners actually had to go through a 6-month trial and error course on how to reduce certain battery usage. So sometimes if you don't have the monetary means of paying someone to do it, then maybe you learn it yourself, and at least you have the skill stay with you. No one can take that from you.
Yeah, actually the question was about the physical resources of the devices.
Ah, right.
Yeah.
Okay, I just saw that now. Yeah, so the physical resources of the devices, once again, it's about the expectation of delivery and expectation of what it is that what you're claiming the device does. It's a very bad bit of tendency of people designing hardware to actually listen to the end customer. The only thing you should listen to the end customer about is what it is that they're trying to achieve and how long they're trying to achieve it. If you allow a customer to dictate to you on the physical requirements of a device and their expectations, you will notice that it goes beyond scope shift, and the physical resources of the device can be impacted by unrealistic expectations, in which your product, irrespective of whether it's a good solution or not, will fail to meet the customer's expectations. So don't try to claim something that is cutting edge technology that they're spending billions of dollars on still developing, that you can do it because you read something. Just make sure that you keep your capabilities and the customer's expectations sort of in the same area. Hopefully that's answered that.
Okay, that's great. I also have a question. So most of IoT applications, they like cloud-based, but recently another platform is introduced, edge computing, and it's suggested for applications like delay sensitive applications or privacy sensitive applications, it's suggested to do some computation and storage locally. So I just wanted to ask you, in terms of security, how is that? Is it a edge-based application is less secure compared to cloud-based IoT application? Do you have any insights on that?
I don't think that they're less secure. They do have a considerably different type of vulnerabilities, and the only thing you can really do is manage the vulnerabilities. So if you have a cloud-based system with a very, very dumb sensor that tells temperature, then you're effectively limiting what that device can do or be recommandeered for. So effectively that device has its own limitations in that somebody may not be able to access it and do something extremely malicious with it. When you start adding computing power to the end device, you're looking at power consumption you're looking at expense. So there are costs because there will be there's going to have to be additional componentry in there. You're going to have to increase the device's memory. The device will be on an on always mode, which means that the device will effectively be scanning and listening all the time. And edge devices definitely, especially with 6G and 5G, Wi-Fi 6, we're kind of looking at that space anyway. And sometimes people's homes are already technically a minor edge device sort of system as it is. But that's within a protected area, and that is within an area where somebody can kind of go out and change something readily. When it comes to say remote, totally remote, as in the infrastructure owner is hundreds or thousands of kilometers away from an edge network, and it's doing on-site calculation and local reporting, I guess that in a way that's the security concerns and security aspects of that is, how will you know if someone has accessed it? Because generally those edge systems will still have a fallback comm mechanism to reach the cloud. So they're not going to be totally left alone, never to be updated or never to be revisited or checked for performance anyway. So that kind of does still have that security aspect that somebody can monitor the potential device or the edge network so that they can check the performance of the system. So it does still have some way of being centrally managed, and also have the security and the IoT security component of it updated or looked at if someone is, as an example, providing false positives. So by that I mean you've got an edge network that's monitoring the health of individuals in aged care facilities where they live by themselves. Now, if somebody maliciously gets into that, they don't necessarily have to do something that's visible. They can just say everything's okay. So once you have an aged care person or someone in aged care and the system's looping over to you their regular life patterns, but the person hasn't moved for 12 hours, that edge system has to be monitored to make sure that it's still holding true to what it's actually meant to do, that it hasn't been compromised. And there are certain ways that you can put different agents on there. Some companies such as Darktrace and Canopy embed something onto the actual edge network, and they do the management and monitoring of the anomalies that show up. And it's those anomalies which could be indicators that something's happened on the edge. Other than that, I think edge is relatively limited at the moment, and it will be for a while, predominantly because of the slowness of the uptake. Corona has done its damage to IoT as well in slowing it down. So it definitely, it's definitely an area that's growing, but I think that we're still a fair while away from having a proper managed edge system.
Yep. Yeah. All right. Thank you so much. Thanks for your time. Time is over and we have to stop here, but your talk was very great, and thank you so much for sharing the insights in IoT security with all of us. All right, thank you everyone for attending this session. We are looking forward to other interesting talk in this week and the next week and the other weeks that we have this symposium. All right, thanks, bye.
Okay, thank you.